based on service-based architecture opens up potentially new vulnerabilities. In a 5G networks, the delivery of service to users occur via data forwarding path, which is established and maintained by the control plane of the 5G CN. Thus, 5G CN security is fundamental requirement for the 5G security. So, you might have guessed our topic for the talk: 5G core network, security issues, and research directions. To introduce to you, Dr. Rajendra Patil is currently a full-time postdoctoral research fellow in the Division of Network and System Engineering at Department of Electrical Engineering and Computer Science, KT, KTH Royal Institute of Technology, Stockholm, Sweden, since June 2022. Previously, he had worked as a full-time postdoctoral research fellow in the School of Computing at Department of Computer Science, National University of Singapore, from April 2020 to May 2022. He has expertise in developing machine learning solutions for attack simulation and modeling, threat intelligence, network anomaly detection, advanced persistent threat detection, cloud network security, and 5G core network security. You might be interested to know he has worked on various industry projects in cybersecurity where he has hands on experience in Python ML libraries such as NumPy, SciPy, scikit-learn, Pandas, etc. He has strong professional with the doctor from National Institute of Technology, Goa, India. I would like to questions in chat box. I would like to request all the participants to drop their questions in chat box. We will cover all the questions at the end of the session or else at last 15 minutes. Over to you, sir.
Yeah, fine. Good morning, all. Am I audible? Good morning, all.
Yeah, we can.
I hope. Yes. Fine. Okay, good morning, all. First, let me congratulate NFSU for organizing this particular month, that is Cybersecurity Awareness Month. And it is just again, I want to thank Dr. Ajit Mujumdar for inviting me for this particular talk, and Harsh Panchal for continuous communication regarding this particular talk. So thank you for inviting me. Just I will today. Just we are going to focus on or going to talk on this one, 5G security. So first of all, you might have seen this 5G is a completely new architecture. So before starting with the actual security issues, we'll go with the 5G architecture. What are the architecture types are there, and uh, we'll go into SA architecture, that is standalone architecture, and then in depth we'll go in the core network. What is the architecture of core network, and how it is uh, getting exploited by the different attackers. So what is the growth rate of the 5G security measurements? So start. So we'll be talking on this. So we'll start with the initial idea of the 5G architectures. So I hope the audience are students, and some audience are parents also. So in implementation point of view or in research point of view, just we'll go in depth for the students, that is how to deploy, means what type of solution security measurements you can deploy for the 5G security. So as my background is regarding related to the network security, so here we'll be talking on network security issues of the core network of the 5G. So we'll start. I hope you'll be enjoying, guys. Okay. So my presentation is visible, right, Harsh? Yeah. Okay. Great. 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 Thank you. So just okay. So I will just. So we are starting with the 5G security, and the my I have another screen. Yeah. So 5G security, 5G core network security issues and research directions. So at the end, we are just focusing on the research direction. What type of means for the students? Already I told, like for the students, it is very focusable topic where they can start, they can initiate the research. Yeah. So first of all, before going into the details, we should know why 5G. So why people are moving toward the 5G, or why so many industries they are focusing on the 5G implementation, 5G deployment. So the basic reason is like diversified service requirement. That is, multiple services are already there, and even some other services are getting deployed in the 5G, but diversified services. What we mean by diversified services, it means like you are going to connect, or people are going to connect multiple devices of different types. That is IoT device, then virtual reality. Sometimes you have health equipments that you are going to connect to the 5G. Sometimes you have different IoT networks of the different sensors where you are going to connect particular your fridge to the 5G network, your TV to the 5G network. Then smart city, if you talk about the smart city, or if you talk about the vehicular network, then particular vehicles are going to connect to the 5G network. So these are the diversified requirements of the services. And by using 4G, that is existing 4G LTE, long term evaluation network, you cannot fulfill all these requirements. That's why there is a need of 5G network. So the if you ask, or if somebody asks you why we need the 5G network, the simple answer we can give as a diversified security requirement. So each, sorry, service requirement. So each service needs a specific network topology. Each service needs specific network function set. Again, here we are going to see network functions. We are going to focus on the network functions, how these network functions are going to be deployed in 5G network. But entirely I can say, if you have particular service, in that service, that particular service has specific requirements, and based on these requirements, the 5G is going to fulfill that particular requirements. And again, obviously, we are talking about the third requirement, or third, the reason, like performance requirement, where you might have seen right now, if you are getting the 4G speed, if multiple devices are going to connect, or if multiple devices are there, which are like billions of devices are there which are connected to the network. So there is a need of performance improvement for the end user. So end user should get high throughput, low latency, delay should be low. Like once you are open particular video, it should start immediately. You don't have to wait for particular like uh, for the loading, or for the other capabilities, or other functionalities of that particular video. So you can say that performance requirements are there. That's why people are moving toward the, or rather than people, I can say industries are moving toward the deployment of the 5G. So I hope you are clear with this 5G. Now, what is 5G network? What is 5G network? So you can say like it is next generation for the 3GPP technology, like 4G LTE. That is next step or next generation of the 4G, you can say. But uh, uh, I can say like it is entirely different. If you consider architecture, the core architecture, it is entirely different from the 4G, and it is completely virtualized. That is, everything is implemented by using the cloud, or by using the software technology. So earlier network functions are hardware based network functions, but right now in 5G, people are converting these network functions, any network function, that is mobility management function or access, management function. All these functions are deployed in the cloud. So we can say that all these functions are virtualized. So now how 5G network is implemented. So they have used existing technology like software defined network, NFV, network function virtualization, and cloud computing. And based on these three technologies, they have implemented the 5G network. You might have seen even in I think in May 2022, IISc Bangalore has successfully what I can say successfully implemented the call 5G call setup. So for that they have used no uh, also in other around 189 countries they have deployed the 5G network, but they have used the 4G as a background processing. So we'll see that how 4G is used as a background processing and how entirely 5G is used for the background processing. So that's why we are focusing on the core network, because core network in 4G and core network in 5G are entirely different. So we can say like why we have to use SDN, why you have to use we have to use NFV, and why cloud. So it is the foundation. It makes the foundation for uh, particular technology, or it makes the foundation for particular what we can say particular service. Like if you have to centrally control the network deployed over the multiple services, then you have to use SDN, software defined network. Then how to use network functions efficiently. Like if you are using 4G network, then for each service you have to use different separate network function set. Like uh, you can say, yeah, separate network function set. But in 5G what you can do, you can share network function set among multiple services. Like same network function can be used for the IoT service, same network function can be used for the smart city, same network function can be used to any other service. So this is the basic difference. So again, cloud computing, earlier you can see that RAN, radio access network, is implemented based on the hardware or some software technologies, but in 5G it is entirely implemented by using the cloud computing. So cloud computing in the sense like you can place that particular RAN close to the uh, user. Like suppose you are in particular region, you have multiple users, so you can give high capabilities to the servers uh, at the RAN at that particular region. So these are the basic requirements or basic foundations of the 5G network. And we can say like in summary we can say like NFV provides virtual network functions while SDN controls them for the specific services for the specific uses. Now we can see the architectures. Now 5G architectures is the fundamental what we can say is the fundamental uh, uh, base or fundamental thing in the 5G network. So in that there are two modes. That is the 5G non-standalone network. In non-standalone network, you can see it is using 4G LTE. That is Evolved Packet Core. It is using for the network processing, for the packet processing, or LTE is used as a core network. So LTE plus EPC are used for the standalone architecture, but people are moving toward the standalone architecture because earlier the core network was not implemented. We can say the like this new radio, that is completely core network plus new radio are not implemented. So we can say that some functionalities of the 4G are equivalent to the 5G. So people are using new radio plus existing core network. We cannot say it as a core network because core network is the new entirely new term in the 5G. So they are using EPC plus LTE in not standalone, but in standalone it is completely different. Like 5G has its own new radio, and 4G uses like 4G has entirely existing setup. So we are focusing on standalone. If you are clear with this one, in next presentation, in next few minutes, we are going with the 5G standalone architecture. So it is completely independent of the 4G architecture that you can see. Now networks. If you see the networks, networks in the 5G network. So you you may get confused about this one. What do you mean by networks in the 5G network? So in 5G SA architecture, there are four networks, and basically, like first one is external network, that is the user equipment, where you miss people are there, like people with mobile device, people with a particular device, people with particular device, or we can say network of the devices is called as a external network for the 5G. And radio access network, again, we can say different towers are there or different base stations are there. In 5G, it is called as the G node B, that is next generation node base station. So again, radio access network is a networks of the these in simple language, it is the networks of the towers. And core network. So basic functionality of the 5G is implemented by using the core network. So core network is used for the establishing the data forwarding path. And when network connection is established with the 5G, the core network will not have that much inclusion in the user service. So core network will set up the control plane. That control plane will handle the data forwarding path of the user, and user will not have any interaction with the core network. So, and again, last we can say data network. Data network is like you are providing the service to the particular user. So at the end, that data is stored in the data network. Like you can say it is the network of different, like data network. You can say it is the network of the public internet services. It's the network of private services. It is network of some third party applications. So you can say the entirely the network of all these services or all these applications as a data network. So for example, you need the service from the Facebook. The user equipment is the device where you are getting the service. For example, yeah, user equipment where you have a device, and that device is going to get the service from the Facebook. So it will first contact to the radio access network, then core network, and then core network will forward that particular request to the data network, that is to the Facebook. So you will be getting this right now. If you are using the laptop, and you have connected your laptop to the network service, or to the sorry, to the internet, then you are getting this particular service as a LAN, then through the LAN, then internet service, and then Facebook. Like through the internet server, you are getting the service through service from the Facebook. But here, this mobile network is entirely different from this particular commercial network or conventional networks. So uh, just see what are the different networks are there in the 5G SA architecture. So basically, there are four networks as we have seen. Now, what do you mean by core network? So core network here, just we are referring this particular term as a set of network functions. Like network function is there, and that network function will provide you particular service in the core network or in the 5G. So this particular service is entirely different from the service that user is getting from the 5G network. So user is getting the service from the 5G network in terms of the uh, face, like for example Facebook, like YouTube, any social media, any videos, any what I can say, like different types of service from the 5G network. But in network function, the service is entirely different. Like where you can say like a particular network function is verifying, is responsible for the authentication of the user equipment. Another network function is responsible for the uh, data management uh, of the user equipment. Another network function is responsible for the responsible for the session management of the user equipment. So session management, authentication, access control, then network resource management, these are the services provided by the core network. And core network can be seen as a set of these network functions. So for particular service, like for the IoT service, you need all these function sets, all these network services. So these all these network services are provided by the core network. Now, how particular core network will provide the service to particular service, or how the entirely core network will provide the service to the core network, that we'll see later on, like in next slide. Just I'm explaining that one. But if you see the basic setup, like user equipment, if you start from the left, user equipment is there, like your mobile device or your IoT device, your vehicle, that is considered as a user equipment. So it is a means you can say right now at the end of, if you see at the end of this 2022, around 1 billion devices are getting connected to the 5G. So these UEs are multiple. Like you can say in particular region, multiple millions of UEs are there. So RAN is responsible to connect your UE to the 5G network. So it will provide you uh, service of the access network, where you, where particular base station is there, you are going to, your user equipment is going to connect to the base station, and then base station is going to forward that particular request to the core network, and core network will uh, handle all the service network related services of the user equipment and provide the service from the data network. So this is the setup. Just uh, uh, have a quick look over this particular setup, because we are going to see this particular architecture, this particular core network in security point of view. So if you see the service-based interface, so it is service-based architecture. Actually, it is service-based architecture, and it is centrally connected to each other through the service-based interface. Now, if you see this particular what is meant by N1, N2, this N4, these are the interfaces, network interfaces, where sorry, particular device or particular component in 5G is going to connect to the another component in the 5G. So if you see what is meant by service-based architecture, so here we can say that uh, uh, particular network function is getting the service from another network function through the service-based architecture or through the service-based interface, and it works as a client server. It works based on the client server mechanism, where particular network function will verify the the request from particular from the another network function. So again, that destination network function is going to verify the response from the source network function. So in this way it works. That's why it is called as a service-based architecture, and all these network functions are connected over or communicate over the service-based interface. And again, just yeah, we can say that this particular core network is responsible for the establishing the data forwarding path in between the UE and data network. So if you see in the black dotted lines are the uh, network traffic or links of the control plane, and if you see red lines or red links, then these are the links for the data network or user plane. Sorry, not data network. User plane of the user or user equipment. Where once connection is established by the core network, UE will connect to the RAN. Then RAN will forward that particular request to the UPF, user plane function, and that particular UPF will get the means will provide the service to UE from the data network through these particular interfaces. So UPF is provided by the core network. That's why it is called as a establishing, like it establishes and maintains the data forwarding path, that is user plane, for the UE from the data network or in between the UE and data network. So I hope you are clear with this one. Like there's a difference between control plane and user plane. User plane of the user is created, we use simple word as created by the core network, and that core, in core network, control plane is responsible for creating the user plane of the user. Yeah, so we'll go ahead with the another concept like network slicing. Now what is meant by network slicing? As we have seen in initial slide itself, we have seen that network slicing, like diversified requirements are there, so multiple and diversified requirements are there, and that's why there is a new concept like network slicing. Because for particular service, we have seen for particular service it needs the service specific type topology, network topology, and service specific network function set. So in this case you need the network slicing. So this particular like innovation for the provision of the multiple and diverse services over the same physical infrastructure, 5G physical infrastructure. So how to create multiple virtual networks. So you can see network slicing is the innovation in the 5G. It is based on the existing technology, but it is the completely new concept in the 5G. So network slicing is there. So particular slice will provide service to particular types of the devices, like IoT devices. You can see there are three types of these basic services we have taken, like IoT services. Again, IoT, another slice is for the IoT, and another slice is for the mobile devices. So you can see, again, these RAN network may be shared among multiple slices or may be entirely different for the particular slice. So control plane is there. This again, dotted line shows the traffic for the control plane, and the plain line shows the traffic for the user plane. So particular device will connect to the control plane. It will establish the user plane, and that device communicate to the data network or that particular IoT network through the user plane. So network slice, the core network itself is partitioned into multiple distinct virtual networks. So you can see for first IoT services, you have entirely different core network. Another, for second IoT service, again, it has entirely different virtual network. And mobile devices, again, it has entirely different virtual network. So providing network as a service, you might have seen in cloud computing, SaaS, PaaS, like platform as a service, software as a service, infrastructure as a service. So if we go behind these services, then network as a service is provided by the 5G. And providing network as a service to the users, we have to use, or they're using, network slicing as an innovation. So now, just we have spent much time on this particular again knowing the architecture of the 5G. Now just we are moving toward the security issues, and then at the end we are talking about the solution directives. So security concerns in the 5G. So just rather than talking entirely in depth over the particular core network, we will see the background, like uh, uh, how particular industries, 5G industries, are facing the network security issue, or what are the security concerns for the industries. So if you see this AT&T cybersecurity industry, they have published this particular article in 2022. So where they have uh, like given the percentage, or they have sorted the different attacks or different types of the threats based on the type of the threat. So if you see in 5G, the entirely different risk, I can say, or entirely different security concern is multiple devices, multiple and multiple types of the devices are getting connected to the 5G. So if you see from the top, you will get top three concerns are related to the 5G only, or we can say are entirely or majorly related to the 5G, like larger attack surface due to massive increase in connectivity, then greater number of devices accessing the network, and again, types of the devices are getting connected to the 5G. So that's why the 5G is facing, like initial setup of the 5G is facing this particular security issues. That's why we have to focus on network security issues of the 5G. Why? Because if you see in machine learning point of view, then uh, first three security issues can be resolved through the machine learning solutions, or you can use artificial intelligence, you can use uh, uh, something beyond, like deep learning you can use. So if you focus on these network, sorry, security concerns, then top three security concerns are related to the network, like related to the network connectivity in the 5G. It may be from user network, external network, that is user equipment network, or it may be from the core network itself. Because you can see, like uh, if you are not still if you are not clear with this particular core network, I can give you an example. Like you might have seen the central admission process, or CCMT, for the MTech admissions handled by the uh, uh, different NITs. So central admission system for the NITs, or CAP system for the engineering admissions. So, or you can say gate exams. So gate exams are centrally handled by the government. But if particular, like take example rather than gate, we can say take another example of the MTech admissions. So particular MTech student will get the admission in particular NIT, but we say this getting admission for particular student in particular NIT is the user plane, but it is established by the government. It is established by the government. So again here it is handled, right now it is handled like handled properly, but consider all these like 12th admission, engineering admission, then some uh, postgraduate admissions, PhD admissions are centrally handled by the government. So we can say this particular central, like central processing as a 5G. So where 5G is providing the multiple services, it is providing the services for the 12th student, it is providing service for the engineering student, it is providing the services for the postgraduate student, it is providing the services for the PhD students. So PhD students, MTech students, these are the services. Again, in particular engineering, there are different branches. So again, if you take simple example in engineering, again engineering is a service provided by the 5G, but particular student in particular student will get particular branch. Again, this is the service, like electrical engineering is the service provided by the government. Again, computer engineering, it is the service provided by the government. So core network is nothing but the, we can consider as a government processing or government, uh, yeah, government service, where government is handling the admission of particular student in the particular NIT for the particular branch. So uh, like this particular setup, you can right now you can in simple way you can imagine what can be the 5G network. Then we'll move toward the security issues of the 5G network. So yeah, so here we have seen the broad network security issues, network security concerns in the 5G network. The rest of the issues are related to the authentication, access control. Again, different apps like critical apps getting deployed in the 5G. So these concerns we are not going to see in detail, but first three concerns, like rather than first three concerns, I can say network security concerns we are going to see in detail in the next few slides. So 5G CN, again, this is the term used in the 5G implementation. That is 5G CN is nothing but the 5G core network. Now network threat surface. So first of all, we have to see where are the different entry points from where attacker can enter in the 5G network, or can means from where attacker can exploit different components of the 5G. So possible entry points for the attackers to get the access or to infiltrate the 5G control plane. Basically, we have identified in our ongoing research, we have identified the five entry points, but there can be multiple entry points. But in broad categories, we have identified this particular uh, five entry points. So if you see in different Ericsson, or if you see 3GPP technology, they have also the focus on these particular entry points. And even they are focusing in their research, they are focusing on the attacks from the UAE, attacks from the data network, attacks from the network function in the core network itself. But we'll stick to these particular five interfaces. Like first one interface, again, we are going from the internal to external. Like first we'll go in the core network. Now what are the attack possibilities from the core network itself? Because you can see, you might have seen the malicious insider. Malicious insider can be the employee in the company, or can be the device in the company which is compromised. So we are going from uh, in radius point of view, we are going from the internal to external. Again, internal to external in the sense that, like first attack point is from the core network itself. Second attack point is from the network slice in the core network. Third attack point is from the manager of the virtual network function. Then fourth attack point is from the user equipment in the external network. And fifth attack point can be the user or devices from the data network. Like sometimes, yeah, we'll see it later. How can be an attack performed from the data network. But these are the five, I can say these are the five entry points from where attacker can exploit the 5G control plane or 5G core network. So interchangeably, we are using these particular words like this one 5G control plane and 5G core network. But control plane again, it is in 5G core network, control plane handles the user plane. So yeah, rather than focusing on the core network, again we will go beyond the core network, that is control plane. So control plane is establishing the user plane for the user. Yeah. So see this particular setup again. It is entirely based on the setup that we have seen in detail in previous slide. So if you see external network is there, then internal network of slices is there, then access network, core network, data network, and management network. So if we have gone in detail, so where we have identified multiple networks. Earlier we have seen four types of the network, that is external network, radio access network, then core network and data network. But here we will get some other networks, that is virtual network, then internal network, then management network, then external network, and last data network. So in core network, you will get three types of the different networks, like virtual network, internal network, and the management network. So what are the attacks in this particular core network? So you can say like threat source is network function. Threat source can be network slice. Threat source can be user equipment, that is your user mobile device can be the source of the attack. Your any device, IoT device can be source of an attack. So if you see, but here I have taken only three sources out of these five sources. So in three sources, like from the network function, you can access the user credentials of the another user stored in the network function, like access management function or AUSF, authentication server function. So where user credentials are stored. So particular network function can attack or can access the user credentials from the another network function. Like after that, malicious NF registration, that is network function registration. So these are the different attacks that are possible in the 5G core network itself. And source is network function. And another threat source we can say like network slice. Like you have different slices in core network. So first slice is providing the service from the IoT network, or consider in this particular figure, if you see slice 1 and slice 2 provide the service to the IoT network. Slice 3 provide the service to the mobile network or mobile devices. So there can be an attack which is which can be performed from the slice 1 to slice 2, or from the slice 3 to slice 1 and 2. So if you see, there are different types of the network functions. Some of the functions are centrally organized functions, some of the functions are shared functions, or some of the functions are the slice dedicated functions, which we can say as a slice specific function, like that particular function will not be shared among multiple slices. So here if you see AMF shared among AMF at the top, if you see AMF is shared in slice 1 and slice 2, in between slice 1 and slice 2, whereas you see NSSF, that is network slice selection function or network repository function or user data management function. These functions are centrally organized function, that is we can say centralized network functions, which are shared among multiple slices. Like these functions will provide the services to all slices, all services in the core network. So just we'll focus on denial of service attack. So where particular network slice can perform, or network function can perform denial of service attack or distributed denial of service attack over the another slice. So that if the particular slice is facing the denial of service attack, that means the user devices or user equipments in that particular service or uh, in that particular slice will not get the service, there will be delay in the service, there will be interruption in the service, there will be a complete denial of the service. So this is particular denial of service attack that is possible from slice 1 to slice 2, or from particular slice to another slice. So in if you see 5G core network if you see 5G core network attacks, then in 5G core network attacks, if you you see different types of the sources, and in particular source, particular attack, you can go in depth. Like just we in depth, we have seen the denial of service attack, where we have different slices, and particular network function in particular slice can perform the like denial of service attack on the another slice. So where again you have to craft the attack in such a way that that will not be detected, or the rate of request will be very high, that cannot be handled by that particular network function, or network function in that particular slice. So again, if you see the third source, that is your device. So that user equipment, generally, yeah, mobile device or device in the external network is termed as a user equipment. So your mobile is user equipment. I repeat, your mobile is user equipment. Your fridge is user equipment. Your vehicle user equipment. So if you see in that particular point of view, then again different types of the attacks are possible over the core network, like DDoS, distributed denial of service, signaling attack, where you can say multiple registration requests to the access management function, because access management function is responsible to handle your request and then pass it to the AUSF, so that AUSF will perform the authentication verification. Once authentication verification is performed, you will get the service from the session management function, because session management function will be established, and your session, that is device to data network session, will be handled by the session management function, and which has control over the UPF, like user plane function. So like signaling attack is possible, then flooding attack. So rather than using signaling attack, what you can do, you can, once you have identified the IP address of the AMF, or once you have identified the identity of particular network function, you can flood the request over that particular network function. Again, the control plane will establish user plane function to you, or to your devices. So that user plane function will be responsible to handling the your request, that is data forwarding path from UE to the data network, data forwarding path from the UE to the data network. So your device can perform the attack over that UPF itself. So again, you have to craft that attack in such a way that the genuine request will not be like genuine request will not be considered as an uh, uh, attack request, or you can say like uh, DDoS attack over the UPF, like multiple. You can create the bot attack. Sorry, you can create the bot of the user devices, and all these user devices or user equipments are the compromised user equipments. So you have bot of these user equipments. So you can perform the flooding attack over the UPF. Like particular UPF is responsible for handling data forwarding path of the user equipments in the bot network. So in that particular case, that UPF will not be able to provide the service to the genuine user equipment. So again, this is the attack. Then DNS hijacking. Again, we can say different types of the attack, like UE masking attack, like where you will hide the identity. That is, user equipment will hide the identity from the core network and will perform the attack. Again, UE deregistration attack, like where you can send the fake request for the deregistration. So uh, uh, where again this will be the impact on the union UE, where that particular UE will not get the service from the 5G. Yeah. So these are the different types of the attacks. Again, you can go in detail. I have focused on the network attacks, but if you go in detail for the other attacks, different web attacks or different application based attack, or you can say different hardware based attacks are also possible. Hardware based attack in the sense like we cannot say as a hardware based attack, but some management related attack, like particular network function in is managed by the virtual network function manager. So again, management related attacks are there, where just like hardware based attacks in the conventional network, you can perform the management related attack over the network function, because network function works as a hardware based device in in the 5G network. Yeah. Now how to deal? Okay. uh, I hope you are means getting interest in knowing the different types of the attacks. But in students' point of view, uh, just I have a question like how to deal with the network attacks in the 5G network. how to deal with the network attacks. So you might have worked means some of the students might have worked over the network anomaly detection or attack classification, where they have used machine learning solutions uh, uh, for the network security. So in that network security, they might have used supervised learning, semi-supervised learning, and unsupervised learning. So basically, in machine learning solution or in deep learning, again you will use different types of the neural networks for the detecting the network attacks. So in 5G, how to deal with the network attacks? So because you might have seen all these network incidents are like all these network incidents or network attacks that we have seen in one of the slides. All these network concerns are reported theoretically, or some concerns are reported practically. But you can see right now they have started deploying the 5G network. So if you are using machine learning solutions for detecting the attacks, then you don't have attack incidents. You don't have attack incidents because attack incidents are not reported. Earlier, if you see in conventional networks, attack incidents are reported, or some people they have implemented the attacks. You might have seen the different network intrusion detection datasets. So these the DARPA dataset, then UNSW dataset, then other types of the dataset, network intrusion detection datasets. These these datasets they have generated in their lab by implementing some attacks. But in 5G, how attack incidents are not implemented, or attack incidents are not reported, attacks are not implemented. Then how you will detect the new attacks that will be performed in the 5G network? Can we use machine learning solutions? Can we use deep learning solutions? Okay, in machine learning solutions, what to use, whether to use supervised learning, semi-supervised learning, or unsupervised learning. So if you go in detail, like in machine learning point of view, then uh, you can say like supervised learning solution cannot be used because you should have labeled data set for this one, where some data means in entire data set you will have some entries for the attack, some entries for the normal. Then you can train your model, machine learning model, over that particular data set, and then you can detect the new attacks. So this is supervised learning. Unavailability of attack incidents, attack patterns, label data. You don't have label data, so you cannot train the model. Second one, semi-supervised learning. Again, in semi-supervised learning, if some attack incidents are reported, then you can label that attack incidents. Like you can convert that attack incidents into the network flow, and that particular network flow can be labeled as a net attack flow. So you can like entirely all attacks are not possible because all attacks are not uh, reported in the 5G network. Some attacks are reported in the 5G network. So you have small set of data where you will get the labeled attack data. So in semi-supervising, if you have small attack data, then you can use network anomaly detection. And in unsupervised learning, yeah, first we'll focus on the semi-supervised learning. Network anomaly detection you can use. Yes, we can use the network anomaly detection. Then what are the existing network anomaly detection systems? Existing network anomaly detection systems, and what are their drawbacks? So if you see existing network anomaly detection, these network anomaly detection cannot be used as it is for the detecting the network attacks in the 5G. Why? Because there are some research gaps, like no proper threat model, like you don't have idea about the possible attacks, possible threats, possible adversaries. Because attack incident is not reported, at least you should know what type of attack can be possible, and that's why a threat model will provide you the possible types of the attacks. So that is also not like proper threat model is not developed for the 5G attacks. Then lack of complete data set in the 5G context, because we don't have attack incidents, we don't have attack patterns, we don't have label data. So again, we can see another angle of the 5G, like uh, if an attacker has to perform the attack, that attack will have completely different pattern in the 5G. will have completely different pattern in the 5G, considering the performance, considering the specific network specific topology, considering the network specific or service specific requirement. That particular attack will have completely different pattern. So by using existing network anomaly detection system, you cannot detect the new attacks. Again, whether these existing systems have they considered these particular like 5G control plane? No, they are not considered the 5G control plane. Right now, people have started focusing on the control plane network security issues. Again, we can say no training, no testing over the 5G attacks. Again, it is related to the first research gap. Again, consideration of limited entry points. The existing network anomaly detection system, they have considered the attacks from the single point, like from the user equipment or from the external network. But in core network, we have seen there are we have enumerated 5 entry points. So that particular all entry points should be considered for the security, that is network security of the control plane. And again, it is last one, that is no consideration of multi-node interaction, because if your user equipment is going to connect to the core network, or if user equipment needs a service from particular data network, to establish the data forwarding path, the control plane network functions communicate with each other. So when UE starts accessing the AMF, that is UE first contact to the AMF, then AMF will contact to the AUSF, then AUSF will again contact to the AMF, then AMF will contact. Again, this is the communication in between the network functions that you can see later on also, how a particular connection starts from the UE and how it will get the service from the data network, or in between this getting the like in between these two processing, like getting the service from the data network and starting the communication, the network functions will communicate with each other, and that particular interaction will be considered as a multi-node interaction, where you cannot apply the existing network anomaly detection system, which is based on the point-to-point network anomaly detection. So we can say dealing how to deal with this particular network attacks. Yeah, so you need the network anomaly detection system, but you have to fulfill, or uh, you have to handle these research gaps in the new network anomaly detection system. Yeah. So unsupervised learning, if you see, you can also apply the unsupervised learning, where rather than focusing on the attacks, you can focus on the normal behavior of the 5G network. So you can train your model only for the normal behavior, and if there is any deviation from the normal behavior, you can detect that particular as a out of box, or you can detect that as a anomaly in the 5G network. So unsupervised learning can be considered in that particular point of view, like you will get unlabeled data, where you cluster the unlabeled data into two categories, like normal and attack data, and then you can train your model. Yeah. Now, how to model the control plane for the anomaly detection? You have this particular control plane. If you see, you have this particular control plane, or consider core network rather than control plane. Consider core network, where you have multiple network functions, and these multiple network functions are means multiple network functions communicate over the service-based interface, and in this they have multi-node interaction. Now, how this multi-node interaction can be modeled? Now, how to model? Like from single source to single destination, you can capture the traffic, and you can say that there's like this particular traffic is genuine traffic, or this particular traffic as attack traffic. But parallelly, you are getting requests from the multiple network functions from the multiple nodes. Then you have to how to model this particular multi-node interaction mathematically or in machine learning point of view. So for that, just I have a question, like how to model the control plane for the anomaly detection. So we can represent that control plane or core network as a graph. So just this is our initial idea, and people from different labs from the Canada, from the US, or from Australia. They are focusing on the graph representation of this particular core network. So where first you will get the 5G core network, or just that particular 5G core network will be converted into graph representation. So in graph representation, you will get the all network functions, all the user equipments, all the uh, like data, like all the points, all the points rather than all the I can say all the uh, uh, like servers from the data network. So or rather than that, you can consider that as a single node, but you can present this particular entire multi-node interaction through the graph. So where you can identify particular, like again you can apply a particular network anomaly sorry, you can apply particular anomaly detection over the graph. Again, you can see there are different types of the deep learning and machine learning solutions where you can apply the uh, anomaly detection over the graph. So simple example I can give is like graph neural network, where you can apply graph neural network to identify a malicious node. Like you can see that is AMF, already there is an existing AMF, but another AMF is contacting to the existing AMF. So that AMF can be the fake AMF or can be the genuine AMF. So that particular, if it is fake AMF, then your graph representation or your graph-based anomaly detection system should identify that as an anomalous node. Again, if you are getting particular fake request from the another network function, then you have to identify that as a anomalous edge. Like edge classification and node classification you can apply over the graph which is generated from the core network. So this is the basic setup I can present in front of you, where I can give initial idea about how to model the control plane for the anomaly detection. So where you can, this is our initial idea, that where you can represent entire core network or entire 5G the components or all 5G components as a graph, and then you can apply the graph anomaly detection over the this particular network. So yeah, now how to experiment, how to deal with this particular like implementation, because you cannot set up even I have seen right now I am working on a project which is from the Cisco. From last half 1.5 year we are just implementing the rather than we they are just implementing the setup in our lab. So it is not like you have ready-made setup for the 5G and where you can do the experiments. No, you cannot do like that, because you have either you have to access this particular industry for the implementation, but they cannot provide you the access, because even we have collaboration, we are not able to do the experiments over their setup, because in security point of view, because 5G uh, in in 5G industries are focusing more on services and security. Services and security in that, in the sense like, first service should be like like service should be fast and security should be high. So in that particular point of view, industries are not providing the access to their infrastructure, their deployment. So how to do the experiments for this particular uh, network anomaly detection? Any idea? Anybody has used any simulation tool? So yes, we can use some simulation tools where we can implement the 5G network, 5G core network. You can entirely, you can like create the user equipments, you can create the network functions like core network, you can create the data network, or you can give the access to the data network. So this can be done through the simulation. So rather than going for the means practical deployment, uh, what we have faced is like you will not get access to the practical deployment of the 5G network. So if somebody has collaboration with the Cisco or with Ericsson, they will not provide you the access to their setup, but they can provide you the another devices like another uh, core network, another slice, means entirely isolated slice. They will provide you entirely isolated this RAN will provide you, they will provide you. But the existing setup, the setup that they have deployed, they will not give you the access to that particular setup. That's why we have to go for the simulation. So in simulation, 5G network simulation, you can simulate the 5G network. So in that, what are the tools that are available as an open source or that are available for the 5G network implementation. So open air interface, if you want to note down, just note down. In future, if you want to need some help about this one, that is how to start the implementation, just okay, we'll see it later on. I'm going to give the direction in that particular point of view also. But these are the tools. Just note down these tools. These tools are available in the uh, available over the internet for the implementation or for the simulation of the 5G network. So again, open 5Gs for the core network implementation, and UE ransing, it is for the UE and RAN. Yeah. Third one, like free 5GC. Again, free 5GC is for the core network implementation, and UE ransing for the UE and RAN. Yeah. So basically, these three tools are other tools are also available, but in our lab we have used these three tools for the implementation of the for the simulation of the 5G network. These words are the confusing, like implementation, deployment, then simulation. If you are doing this with this, if you are interacting with these particular tools, then it is network simulation, 5G network simulation. So you can use these particular tools. Again, in open air interface, what we have done, just in that particular point of view, I can give you some directions. Like we have used open air interface for the implementation of the 5G. So here we have used user open air interface UE and open air interface GNB, like node base station, that we have implemented on another machine, on first machine. On second machine, we have used 5G, that is open air interface 5G core network. And these interfaces, like all these functionalities or the help regarding the implementation and deployment is available over the internet. And even if you are interested to do the research in this particular 5G core network security, you can contact me later. So you can see all components of the 5G are implemented using the open air interface. And if you see where is the data network, so open air interface core network, open air interface 5G core network will provide you access to the external data network through the N6 interface that you can see at the bottom. Like there's a connection from the UE to RAN in red line, red dotted line. Connection from the UE to RAN to UPF, like OI UPF through the N3 interface, and from the UPF to the external network through the N6 interface. Yeah. So you can do the experimentation through these particular simulation tools. Now, uh, how to deal with the network packets? Again, in students' point of view, just I'm going in detail where they will get an idea that is how to capture the packets and how to apply the network anomaly detection. So this is the interface, whatever I have marked in bold line, red line. That is the SBI interface, service-based interface, and control plane traffic monitoring for network anomaly detection, where you can capture the traffic from uh, where traffic from all the network functions in the core network. So where you can again filter the network functions which are in the core network, or components which are in the core network, and some components which are outside the core network. So in that particular point of view, like again, you have to model this as a graph, and then you have to capture the traffic, and then you have to implement. Then you have to extract the flow from one virtual machine to the another virtual machine. One virtual network function to the another virtual network function, and then you have to classify whether that particular link or whether that particular flow or whether the network flow in between two network functions is genuine or attack flow. Yeah. So just this is the entire idea that I can give you, I can present in front of you, and just we can go for the conclusion, and then we'll have some questions. Yeah, I'm happy to have some questions. Like, okay, just we'll conclude. Core network, a key component or fundamental component for the implementation of the 5G network technology. or 5G architecture, we can say. And vulnerabilities in current implementation of the different 5G components, maybe from the network functions, maybe from the network slice, uh, or vulnerabilities in the SBI interface. Due to these vulnerabilities, again, there is an increasing uh, network attacks, and there is an increasing need of the network security, or network security for the core network. Need to identify. We have to identify the network security challenges. Again, we don't have data. We don't have attack incidents. We don't have attack patterns. We don't have label data. Then how to detect the network attacks? How to detect the new network attacks of the project? So, uh, in that particular point of view, again, we can identify already we have seen the network security challenges, and also we have seen the future security requirement, like there is a need to apply the anomaly detection system. There is a need to classify. Means you can also apply the unsupervised learning, where you can classify the junior, or you can train your ML model over the normal for the normal behavior only. So in that particular point of view, you can think in research directions that can be help that will be helpful to counter the network attacks against the core network. Yeah, these are some references. I can give you the access to these particular slides later. Okay, thank you. If you have any questions, please. Yeah. First of all, thank you. Thank you for the patience. I think in chat box. Yeah.
So we have one question coming up.
Yeah.
So as you said about the standalone network, won't it be creating the same problem which Geo and 4G did? They were non-operational in the areas where there were no 4G. The standalone 5G won't be using prior services like LTE.
Right now, these around 189 countries they have implemented the 5G, but right now again they are using the 4G LTE as a background processing. New radio, some of them are, I don't know exact number, but some of them are using the new radio. But again, at the background, they are using evolved packet core of the 5G. Sorry, of the 4G. So if you see, if you have to start in research point of view, it is better to entirely focus on the 5G standalone architecture, because some of the network security issues of the 4G are already resolved by the 5G implementation. If you see some of the network issues, security issues like network slice concept, the attack in core network itself or attack in EPC itself are broadly resolved by the broadly resolved by the 5G, we can say 5G SA architecture itself. Yeah.
Thank you, sir.
In research point of view, again, Ajit sir.
Yes, sir.
Yeah, in research point of view, if they have some initial ideas, again, they can go ahead. They can ask the questions like, if they have means if they have some existing setup or existing hands-on over the machine learning solutions, then how to extend these machine learning solutions or deep learning solutions or artificial intelligence. Because see, they can start with the initial research, but I can say like artificial intelligence will have uh, what I can say, artificial intelligence will have good impact in the 5G network security or 5G security itself. So again, you can start the research with the artificial intelligence. Right now, you can see different articles from the major companies, major industries like Cisco, like then uh, Ericsson or other 5G implementations. They have started means how to use artificial intelligence for the security point of view, or from the optimization point of view, or for the performance improvement point of view.
Sir, students here actually they are from the forensic and the digital forensic background. So
Yeah.
DFS and the cybersecurity students. So they are having the hands-on on the forensic tools, but
Okay.
they have just started AI and the machine learning in their labs now. So
Yeah.
they are in the few months, hopefully they'll be expertise in these languages. And they'll start working on this ML and AI platforms to provide the securities and those solutions.
Yeah. Fine. Fine. Fine.
Anyone is having a question? Vinayak, you can directly ask. Sir, one question is there.
Yeah. Yeah. Welcome.
Sir, is the SD of 5G architecture is available for general public like of major companies? Because in the IMC, Sony Ericsson just said that they are developing it for the industries and all those things.
Yes, yes, yes. Still, the SA complete SA architecture is under development. People are saying like we have implemented the call. Just I have seen, I have given you an example like in ISA also they have implemented the 5G call, but they have used the existing 4G LTE, 4G EPC. So SBI architecture is implemented, but actually I cannot say it is whether it is deployed or not. Means I'm not sure about the deployment, but 5G around in 200 countries 5G is implemented, 5G is deployed, but they have used 4G as a background processing, or we can say EPC as a background processing rather than core network.
Any other question?
Thank you, sir. That would be all questions for the today. I don't think anyone has any further doubts. So, can we end this session right now?
Yeah, fine. Thank you for the opportunity.
Thank you, sir.
Thank you, sir. It was a nice and interactive session.
Yeah, fine. Thank you.